Hello everyone, in this video we are going to see about the structures of multiprocessor operating system. Initially we should know what is a multiprocessor operating system. So as the name implies, there are many processes, multiprocessors, and naturally the operating system should be able to handle these multiprocessors in an effective manner. So when you say a computer is a collection of memory, IO and processor. So now how this memory is going to be shared between the multiple processes is the main issue, because memory contains all the data and the data has to be shared among the processes. So in order to maintain these things, naturally we should have there is some address space. This is an address space, the common address space. So address space is the collection of memory addresses. Okay, so now a multiprocessor is a tightly coupled system where there is a shared address space. That means the address space is common to all the processors. Every processor can access the common memory space. So they are tightly coupled. That means they are communicated. They have to depend on one another. That is called as a tightly coupled system. So here a multiprocessor operating system controls and manages the hardware and the software as if the user sees it as an entire uniprocessor system, but the system has inbuilt, it has all the arrangements to make it as a multiprocessor system. Actually, when there is multiprocessors, naturally there will be a speed up in the processes. So how they are connected between each other, that is done by the interconnection networks. That is the definition of the multiprocessor systems. So naturally the multiprocessor operating system has to be implemented, and only they can handle the multiprocessor systems. Okay, so now here let us see the various types of this multiprocessor system. So one is the tightly coupled multiprocessor system. As the name implies, the memory is shared among this multiple processors. So the memory is common. Each processor can access the common memory area. That is called as a tightly coupled multiprocessor system. So what is the quality of this systems is the data rate is high than the loosely coupled multiprocessor system, because they have a shared memory. So the data access rate will be higher, and then the modules are connected through the networks. As we told you in the definition, they are connected by the networks. So what are the networks? They are all the processor memory or IO processor or the interrupt signal networks. They are connected through the networks. Let us see the structured diagram of this tightly coupled multiple processors. So here we can see processor P0, P1, etc., and likewise IO 0, 1, many IO, so many processors and many modules, M0 and M1. So there should be a memory, a processor and IO for it to define a computer. So here multiple processor, so multiple memory modules and multiple IO modules, and they are all connected by the common networks. So what is the networks here? To connect between the processor and the memory, we have the PMIN. That is the processor memory interconnection network, PMIN. To connect the processor and the IO, we are having the IO pin, which is the IO processor interconnection network, and then we have the interrupt signal interconnection network, which connects between the processor and the memory. Okay, so now this way we have, there is a local memory here. This local memory has to be commonly shared by all the processor. So there is a shared memory here. There is also a local memory here. This local memory is mapped using the memory map. That means every processor can have some local memory which will be assigned by the memory mapping technique, so that the processor can use as the local memory also, but commonly they are using the shared memory modules. That is the major concept of this tightly coupled multiprocessor systems. Now coming to the loosely coupled multiprocessor system, as the name implies, they are independent of each other. They are loosely coupled. That means they have a distributed memory instead of the shared memory. And the memory is common. Every processor has to access the same memory area. So there will be a good communication between those processors. But in the case of loosely coupled multiprocessor system, every processor has its own memory. There's a distributed memory is distributed between the processors. So naturally the data rate is lower than the tightly coupled multiprocessor system. When you say data rate is low in the sense that the amount of data transferred between the two modules is low, that is the data rate, and then the modules are connected to the message transfer system, which is MTS. And then let us see the structure diagram of this loosely coupled multiprocessor system. We can see they are independent computers. They are distributed on another part. So this is one module and this is the another module. So this module has its own processor, its IO, its local memory, and this is a channel and arbitrary switch. So this switch will helps to switch between which module is being under processed as under communication. And likewise another module which is have its own processor, IO, local memory, and the same channel arbitrary switch. So this switch helps to switch between the multiple modules of the whole system, and they are all commonly communicate through the message transfer system. So this is the model of the loosely coupled multiprocessor system. So now coming to the shared memory multiprocessor, there are three models which are UMA, that is uniform memory access, NUMA, which is non-uniform memory access, and NORMA, which is no remote memory access. As all the name implies, since they are having the shared memory, the tightly coupled multiprocessor have the shared memory area concept. Okay, so when the memory is shared among the multiple processors, the memory access will be different accordingly how the processors or the devices are located. So naturally we are having uniform memory access, non-uniform memory access, and the no remote memory access. Let us see one by one what is UMA, which is the uniform memory access. So when you say uniform memory access, all the processors share the physical memory uniformly. What is the term uniformly? Means that all the processors have the equal access time to all the memory words. Okay, that means the distance are unique or uniform, so the access time is also uniform. They are equal, and then each processor may have a private cache memory. So once they access the memory, they can take the content and put it in a private cache memory and keep it for its own use. Same way, the peripheral also can be accessed as privately. When all the processors have equal access to all the peripheral devices, then it is called as a symmetric multiprocessor. That means a processor having a shared memory area and they can access all the peripheral devices. When all the processors can access to all the peripheral devices, it is called as a symmetric multiprocessor. In cases it is necessary only where few processors can access the peripheral devices, in that case it is called as an asymmetric multiprocessor. Okay, so next one is the non-uniform memory access. As the name implies, the access time varies between the dependent upon the location of the memory word, because the memory is not uniformly distributed. So naturally based upon the distance and the location it is placed, the access time also varies. Okay, so here the shared memory is physically distributed among all the processors called as a local memory. That means every processor has its own share of memory, so that is called as a local memory. And all these local memories form a global memory, which is a global address space, which can be accessed by all the processors. What does it mean is every processor has its own local memory to access. Same time all the local memories are put in a collection of called as a global address space. All the processors can also access the global address space, in the sense that the processors can access both its local memory as well as the global memory. Local memory is its of own processor and global memory is of the common or to all the processors. So this is how the non-uniform memory access takes place. And then the next one is the NORMA, which is no remote memory access. What does it mean is every part of module acts as an autonomous computer. When you say what is a computer, it is a combination of three major components: the processor, the memory, and the IO devices. So here we have the concept of nodes. So there are nodes, and every module is called as a node, and every node has the distributed memory multi-computer system. That means every node has its own processor, local memory as well as the IO devices. That means they can act independently as an autonomous computer, and only for some reason or for some scenario they have to communicate between each other. So that means all local memories are private and are accessible only to the local processors. In the previous model we have seen in the non-uniform memory access, the processor can access local memory as well as the global memory. But in the case of this NORMA, there is no remote access. That means the local processor, any processor can access only its local memory and they cannot access the global memory. That is called as no remote memory access. That means the processor cannot access any memory in a remote way. That means every processor can access only the local memory, because every model is defined to be an autonomous computer, like where they can have their own local processor, memory as well as the devices. So this is how the three architecture of the shared memory works in the case of an tightly coupled multiprocessor system. So that's all about the structures of the multiprocessor system. Hope you understood the concept of what is multiprocessor and how the multiprocessor architecture is designed. Thanks for watching.